Recording. Recording in progress. So welcome to Lecture 5. This is actually our environment lighting lecture. So the one thing about today is this is Project 5, lighting. And it becomes Project 6. Materials. And one environment becomes Project 7, texturing. So do not throw anything out. Make copies, because if Maya takes your stuff and corrupts it, you're going to be out. So always have copies somewhere, make as many copies as you need, put it on the cloud, put it on a hard drive, put it in another location on your computer. Back it up, please. You should be doing that all the time anyway, because anytime you go anywhere to work, you're going to be backing assets up to various places, depending on where they need to be. All right, so we're going to be doing an interior environment and an exterior environment. Whichever one you choose to do the daytime version of, you will do the opposite environment, opposite time of day. So if you choose to do the interior daytime, you will do the exterior nighttime. If you choose to do the exterior day, you will do the interior night. This way you will get two different environments, two different times of day. And also for this assignment, you will get a chance to do a MyComp practice. Well, it's going to be a small portion of the grade, but it's a good chance for you to find some reference of an environment, take our geometry, rearrange it, however it needs to be, so you can get the look and feel of the reference. Sort of like what we did in Project 1 and 2, only now you're going to be responsible for everything. Camera, lighting, color, the whole, just everything in general. The only thing you can't do is model anything or import from another scene. Again, it's all about the layout phase. So we have two downloads for you. We have Project 5 Interior Zip and Project 5 Zen Garden Zip. All right, so our Zen Garden is actually a real location. It is behind building 4D. So if anybody's familiar, you guys are familiar with the 4B 3D Arts building, right? So if you guys know how to get to the back way from here to 3D Arts, right? Walk the back lot over the bridge, around the corner, and it's right there. If you continue around the corner of the 4B building, you'll see the Zen Garden on the far side. So actual physical location, we took pictures of it. Your lab instructor, Frank, modeled it for us, did a great job. Frank also modeled the interior, by the way, did a great job on that as well. So we actually have photo reference for you of the Zen Garden. Plus, I highly encourage you to take a walk over there, take your own pictures, look at it, get a feel for what the actual environment looks like. Now, from what I understand, it may be a little dirtier than some of the pictures. I'm hoping they kind of cleaned it up since we're trying to get everybody back to campus. Yep, no problem, Blaine. So, like I said, totally worth going over to take a look at so you can get an idea of where it is, what it looks like, what it feels like. You can see the actual textures, you can see the lighting. So the daytime version, the lighting was done at 10:30 10:30 in the morning in November. So the light direction is going to be a little bit different back there in August, but you'll still get the idea for how the light falls in the environment. Let me just grab a quick screen here, make sure I get everybody. There we go. Okay. So office hours, tomorrow I'll have it 10 to 4, Discord office hours. Frank or Ari will also be doing the Zoom Open Lab tomorrow. This is optional, as always. For online and campus students, there is a separate link if you're a campus student in the schedule that I have in our course overview activity. Down at the bottom, that's the link you use for the Open Lab. It's not the same link that we use for lecture. So that'll be 1 to 5 p.m. Eastern Standard Time. And then next week, I'll have office hours Tuesday from 10 to 4. All right, so for today, interior lighting, what the camera sees, basically trying to interpret camera exposure, meaning how much light does the camera let into the sensor. That's a big deal because camera sensors see light differently than human eyes. So there's a couple of things that we're going to talk about in the next slide about what the eye sees, what the camera sees, and how we kind of compensate in our CG to accommodate what looks natural to us. So we've also got exterior lighting, time of day, shadow length is very important. Color temperature will be used now instead of just changing the color inside the attribute of the light. Whether it's a directional light, whether it's a spotlight, a point light, an area light. And today we're going to be working with dome lights and portal lights, as well as mesh lights. Mesh lights allow us to turn any piece of geometry into a light emitting surface with controls, just like a normal light. Okay. So again, day versus night lighting. Linearized colors, that's going to be part of color management. As long as you have color management turned on, then it will function appropriately. Just like the light will fall correctly, the colors will display correctly. All right, so real quick screenshot, just make sure I get everybody. Anybody have any questions so far? Thank you, Louis. Anybody in Zoom? Questions? Joshua's good. Jerry's good. Nate. Okay, very good. Thank you. Maddie's good. All right, so let's talk a little bit about camera exposure, how cameras interpret exposure, how our eyes interpret exposure. All right, so when we look outside the window, so if we were to walk outside of our classroom here, go out to the back door on the left, take a look outside, our eyes would be able to adjust to the light level outside and then adjust almost immediately to the light levels inside. So as we looked back and forth, they would both appear to be very natural looking to us because our eyes can adjust a whole lot faster than a camera can. Now, in order for us to get our pictures to look correctly, we have to make a couple of decisions. One is going to be which exposure, if our camera is looking from the inside out, which is more important to us? Is what's outside more important or what is inside more important? Now, a lot of times if you're in an environment, what's outside is purely just, kind of decoration outside the window because we're focusing usually on what's going on inside. So, but that's not always the case, but usually. All right, so I have two images down here at the bottom on the left, inside, and they were both taken with the same camera. I had manual control turned on for the camera, so I had manual color balance, manual shutter speed, manual aperture opening. Pretty much everything was just manual. I was trying to see what it took to get the picture to give me what my eyes saw. So when I was inside, if I looked outside, this is what I saw over here on the left. That looked natural. Now, when I changed my direction or my head and with my eyes just looked around, this is kind of how bright I saw my environment. But yet a camera can't do that. It has to have pretty much a global setting to be able to control how much light is there. Now, there are ways around it. You can shoot raw images. You can shoot high dynamic range images. You can process them in Lightroom and Photoshop, get them to look good. But generally, that looks a little on the artificial side because we're used to seeing images differently. All right, so what I wanted to do was find out, okay, what did it take to get this image outside to look good, right? Stood there, set up the exposure. But the thing is, this made the inside too dark. So here, the inside looks correct, but the outside looks overexposed or kind of blown out. This would be underexposed. So over here on the right, this is done full automatic cell phone camera. I just took a picture inside. So sitting at Denny's, take a picture. They always have interior lights on. Camera sets itself up, or my phone sets itself up pretty quickly to, get a good idea of how much light is in the environment and how to set the camera up. All right, so inside looks correct. And again, outside, overexposed. So I sit my phone or my camera on the window, let it get set up or let it adjust itself for the light levels outside. So now outside looks correct. And this is all within 15 seconds of taking the previous picture. Outside looks correct. Inside looks underexposed or too dark. All right, so these are the same vehicles right here. Same vehicles. This is pretty much the same as this up here. You can see how much more detail I have in the sky versus what I have in the interior with the camera set up for what looks good inside. All right, so for us, if you look pretty much at almost any picture on the internet of an interior during the day, this will pretty much be what you see. The photographer will usually set it up so the interior looks natural, looks correct. They will let whatever's outside the window overexpose or get blown out. We're used to seeing those images. They happen all the time. Does that make sense? Questions? So now you may go somewhere and work where they go, you know what? No, we don't do that. We like our images to look like they're high dynamic range. We want the inside to look natural. We want the outside to look natural. That's great. That's an artistic decision. But generally, if you're trying to make something look photo real, which is usually shot with a camera, you're going to keep the interior looking correct, looking, correctly exposed with enough light, and allow the outside to get blown out. All right, so just take a quick look. Let's go here. Let's just take a look at some images just real quick. Living room day. All right, so here's a pretty good example. Outside blown out, inside looks pretty good. Here, this one, not so much. This one, well, besides everything looking squashed and compressed, it really looks like it's been highly processed. You get something like this. Again, we saw that. You have something like this. You can see the reflections in the glass. So, like I said, depends. If you've got glass, it's going to look a lot more washed out because you're going to have glare and reflection on the glass. You're still going to have a super bright environment. Notice the sky is pretty much blown out. But I mean, that looks correct. Something like this, that looks CG. Actually, especially with that shadow of the lamp there. I mean, it looks like they phoned the lighting in, honestly. Like everything just looks, all the shadows just look like somebody came in with a Photoshop soft brush, or they just, I don't know. I can't look at it too long. There we go. All right, but you guys get the idea. All right, so here is something that is typical of what you will see, and this kind of is what we're going after for our environment. So here's a photo photographer took, right? They did the normal, inside looks correct, outside's a little blown out. And we're going to talk about this on a couple different levels. First, what kind of lights happen in the real world, and what kind of lights do we use in CG as counterparts? Sort of like what we did with the portrait guide, where we talked about what the photographer used and then what would we use in CG. So what is the main light source in this scene? The sun. I would agree with that, absolutely. So sun is main light source. So what would the equivalent for CG be for us? Yeah, directional light. Good. All right. So is the sun the only source of light that we see in this environment? What else do we get besides direct sunlight? And let's classify sunlight as being direct light. That's the stuff we can see when it comes in through the window, hits a wall, or, is on the ground creating shadows. So what else is out there? Those are lights, but they're not on. Okay, we would definitely get reflected light. So if you take a look at the door here, we've got direct sunlight coming in. You can see it hits the door with so much energy, it completely blows the texture and the color out of the door. Then that bounces off of the door onto the wall. There's still a lot of energy. Look at the wall. The wall is almost blown out too. So from the wall, it's going to hit the floor. It's going to go up to the ceiling. It's just going to start bouncing around. What else happens though? Does all of the sunlight make it to Earth? What happens? Well, that's true, but for our purposes, whatever makes it to Earth, depending on where the Earth is pointed at that time of day, clouds, sky. Remember, some of that light goes through our atmosphere with the different levels of gas and gets dispersed there. That's why when we look up and there are no clouds, and hopefully the sun is behind you and you're not looking directly at it, getting blinded, that you will see that nice, really blue sky that we have, right? That's result of sunlight being dispersed through all the different levels of gas in our atmosphere. Things that keep our oxygen, keep our, all the other mixtures that we have in air besides pure oxygen. All right, so we've got sky and clouds. Okay, for that, in CG, we would use what is called a dome light. A dome light will surround your environment automatically when you create it. Doesn't matter how big your environment is, that dome light will adjust itself to completely surround whatever you've got in your scene. Now, what we have going on here with our sky, right? So the dome light kind of takes up that indirect light that the sun, that light that surrounds us, even when the sun goes behind the clouds and it's very overcast outside and the shadows are really soft. What else happens in our environment? So not all the sunlight makes it through the windows. The sunlight that doesn't make it through the windows and the sky light also gets dispersed when it hits the ground. So if it doesn't make it in through the window, it's going to hit a building, hit the ground, hit cars, hit trees, hit grass, hit us, and continue to bounce around. Some of it will find its way into the environment. That would be all that reflected light and color picked up from our surroundings. In Florida, lots of greenery. Here in this picture, you can see there's a lot of green outside the window there. That is all going to bounce light and color into the environment. So with our dome light, we add an image, and not just any image, a high dynamic range image. The reason we use high dynamic range images in dome lights is because we can take the information in the image and use it for light and for color. So when we have a dome light, that will add in color and intensity based on the levels that are built into the image format. High dynamic range means it has enough exposure information in there to provide light source information in an environment. It's not just going to be a picture that you see visible, it's going to actually provide information. Does that make sense so far? Questions out there in Zoom? All right, Jerry's good. Josh is good. Katie's good. Okay. Maddie makes sense. Good, thank you. Now, so for our environment, let's do just a quick, so this would be a crude representation of our dome light. So this would be kind of a crude representation of our environment. We might have like a door, some windows. So our dome light completely surrounds the environment. Now, if the camera is inside the environment, it doesn't really make sense to calculate light in a 360-degree dome. Especially since we're not going to see 360 degrees of light. So in this environment that we're in, we're seeing a very small portion of that huge dome that's outside the windows that we would call planet Earth. So it doesn't really make sense in CG to calculate all of that. So what we use are called portal lights. Portal lights are attached and work with the dome light to take all the dome light intensity and color information, the pictures, the images we have in the dome light, and funnel them into a smaller area. So for the dome light, we would have something that would look sort of like this. We would have create our dome light, put our image inside the dome light. So it'd be dome light with image. And then what we would do is we would create portal lights, which look a lot like area lights. And you can have as many as you need for your environment. You just make them, make sure the dome light's selected before you create a portal light so it knows what to attach itself to. Now, here's the deal. With those, once you create one, it kind of shuts down the visibility of the dome light and only takes all of the dome light information and puts it into a portal light. So if we have multiple openings, we would create a portal light for each opening. So for our interior here in the room, we've got two doors. Next to each door, there's a rectangular window. In each door, there's a rectangular window. So we would create 4 little portal lights and funnel all of our information outside of our little room here in through those little portals. That way, we're only calculating a small area rather than 360 degrees. What does that mean for us? It means slightly less noise when we go to render, because we're rendering and cleaning up a smaller area versus a big giant dome. And when we get into demoing, I'll show you guys how to kind of adjust that. It makes sense to do that. Now, just because we've got a directional light for the sun, we've got a dome light for the clouds and the sky, we put portals in to funnel all that energy from the dome light in through windows. That doesn't mean that in CG we get a one-to-one correspondence of energy return. We don't get as much bounce light in CG as we do in the real world. So anytime we've got areas that require a lot of bounce light energy, for example, this light coming off of the door, the light coming off of the wall right here, even the floor, we would probably need to create some fill lights. Could be an area light. Area lights make really good bounce cards, as you guys found out working with the portrait. It also makes a good bounce card to kind of take the shape of that door, which is going to be kind of a rectangular shape, and bounce it into the environment. So we can use them to kind of add additional energy into our scene. Walls, floors, ceilings, they're all good places to have light look like it's bouncing around. Now, we may get some of that. Like I said, we'll get some bounce light just because we're using global illumination, but not enough to rely on it filling the entire environment. All right, questions so far? Make sense? Questions in Zoom? Okay. All right, thank you. So daytime, little bit different than nighttime now. In nighttime, what is the main light source here? Yep, I would agree with that. That's going to be the lamp right up here. Now, this is a little bit different than the interior day that we just saw, right? A lot of the energy coming in through the window. We had sunlight. We had environment light coming in. Chances are that environment is an open environment where that picture was taken, meaning there's probably a lot of windows off camera too, or the photographer threw in a bunch of lights. But here at night, artificial lights are going to make up the bulk of your lighting. You're not going to get that much from the environment unless you're in a city where there's a lot of lights, or maybe a parking lot or something like that. But guess what? Even in a city, even in a parking lot at night, those are still artificial lights. They are not natural lights. So we've got an image outside our window here, but that doesn't really provide us with a whole lot of light information. It'd be like you walking into your apartment or your home, all the lights are out inside, the windows, the blinds, curtains are open, and you're trying to navigate around in that environment, not step on the dog or the cat or stub your toe or step on a Lego or a plug laying on the floor. All the things that we step on all the time. Stub your toe on the end of a table. So we have a dome light here, but it's not really providing a lot of energy into the environment. Honestly, it is just providing us with visual interest outside the window. So dome light, again with HDR I for imagery. And again, not main light source at night. But since we're inside, artificial lights. For us, those would be mesh lights. Now, if your environment is modeled correctly, the modeler will have light fixtures, and generally they will provide light bulbs as well. So those light bulbs can become light emitting surfaces. We choose them, turn them into mesh lights so that they emit light. And guess what? Your light direction is automatically taken care of because they are in the correct location where that light source is. So for example, ceiling light. This has an open shade at the top, open shade at the bottom, so it lets light out from the bottom and lets light out at the top. Now, is that the only light source in the scene? What else is there? Well, the city lights, but that's really just kind of eye candy outside the window. It's not really going to provide us with much light if we turn off all the lights in there. We'd see a little bit, but it would be really close to the window and it would fall off pretty quickly into the environment. The moon. Where's the moon? Say that again. Yeah, over here. Kind of looks like they found a light and either they took the shade off of it and put the light behind this entertainment center, or maybe it's just one of these globes here that lights up they put on the floor. But that's really there to act like a kind of a backlight, just so that this entertainment center doesn't run into the backdrop or outside. It's really there just to kind of add a little visual interest and separate it. But it's still a valid light source. So even though we can't see that, we would still need to create, if this is our scene we're working on, we would still need to create a light source to get that effect. So since it's not visible and it probably wasn't modeled, what could you use? Yeah, you could use a point light. What else? Yeah, honestly, you could use whatever gives you the look. But honestly, if it's a bare light bulb, probably a point light would be the quickest and easiest solution because it's going to illuminate in all directions. Now, you could do it with a spotlight. You probably have to put it up somewhere over here and make sure it covers the area you need it to. It's going to have a soft edge to it. It's going to have some drop off or fall off in it, but it would work. But point light probably be the go-to first for me, just because it looks like a bare light bulb. Right, does that make sense? Right, questions? Anybody? Campus, Zoom? Discussion, okay. All good, all right. So shadow length outside. So two different images. This is the Zen garden here. 10:30 a.m. in the morning. You can see pretty decent shadow length. Sun's not directly overhead. If the sun were directly overhead, the shadows would be directly under this little travel mug. And take a look at the edges of that shadow. It's not really all that soft. It's still pretty hard, but not completely razor sharp. All right, so this is 4D. Over here, this is 3D arts. building 4B. And 2 p.m. in the afternoon, you can see shadow almost the same length, maybe a little bit longer. Still kind of a hard edge shadow. The sun shadows are not really going to get soft until the sun is really pretty low in the sky. All right, so here's a CG example from the Zen garden. You can see that, you want to try and keep your shadows to match the real world. So here, shadow length, this is August, a couple years ago, about 5:30, 6 o'clock in the evening. And you can see that the shadows are really pretty long. They are a little softer, but they're not super blurry on the edges. And that's something that people tend to overdo with sunlight. They get the idea that, oh, long shadows have to be really soft with the sun. Not the case unless you are at dusk, where the sun is like right on the horizon, or right at dawn, where everything is super long. So now we get into nighttime. Well, this is dusk. So the sun is very low, could be dawn. With the sun very low, there's very little light in the environment. And mostly the light that we see is a result of backlight. The sky is going to be brighter than the environment itself, because all of those light rays are kind of grazing right across the surface of the earth. So we don't get much light directly hitting the ground and bouncing around. So very little direct or indirect light. We do see a lot of silhouette. Even at night, when there's no sun and no moon, go outside, the sky is always going to be a little bit lighter than the environment. You can always see silhouettes of trees, houses, mountains, wherever you happen to be. Now, exterior environments, generally, we are going to have a lot of small artificial lights when we're dealing with exterior. Unless, of course, you are in like a sports stadium where they've got those huge lights overhead and they just light up the entire stadium and field. But most of our gatherings, most of our outings, you go outside at night, you're going to have a few artificial lights outside to provide light. And the thing that really makes it feel like nighttime in CG is that contrast between light and dark. You don't want to have too much light in the environment. You want the light to be focused and come from those artificial light sources. So here, got a bunch of these little tea candles and regular candles. They could be LED lights, they could be candles with flames. It doesn't really matter. It's still pretty small light, pretty localized. So you have a bunch of them around. Just like you go into your room or go into your apartment, right? You'll have usually a lamp or maybe a couple of them turned on. Those will be your light sources. Go into another room, you flip a light switch on, you might have an overhead light, you might have a bunch of little ceiling lights like we do here at Full Sail in our environment. Just take a look around in here. Lots and lots of artificial light in here, right? All those lights in the those recessed lights that go around the perimeter of our room here. Let's see if I can make this so everybody can see. Let me just kind of tilt that back. There you go. Quick shot. All right, questions? Make sense? Comments, discussion? All right, so One of the things that I highly encourage you to read, if you read nothing else that we provide, is Jeremy Burns' Chapter 8, The Art and Science of Color. He goes into a lot of detail about color and about how it affects our life. He's also got some really good color tables of how different light types equate in RGB, and in this case, there's Kelvin, in degrees, RGB 0 to 1, RGB 0 to 255 or 256 steps. So this table is a really good table to have as reference. So table 8.1 from here, I highly recommend you go there, take a screenshot of it if you want. But he's got all of the different color temperatures for common lights that we're used to seeing, natural and artificial. Now, quick question, why do we talk about light in Kelvin? I mean, we've got lumens, we've got candelas, we've got kelvins. You know, anybody know anything about Kelvin and why it's called Kelvin? What's that?
Something relating to heat?
Sort of. It's a name that would be, yep, that would be a good guess. Yeah, you know, could be we measure in Jerry's, or we measured in Isaiah's, or Lewis's. So Kelvin was an 18th century physicist. He found when he took a block of carbon and heated it, it started to glow different colors at different temperatures. So just like the flame of a match, you have the center, which is usually whitish, and you have on the outside of it a little bit of a blue, and then it goes into the reds and the oranges after that. All right, and usually, you know, we associate that with different parts of the flame are different temperatures. And if anybody's ever done the thing when you're a kid, you run your finger through the flame, and if you put it through the right part of the flame quick enough, you don't burn your finger. But if you put it through the wrong part of the flame and are too slow, it does burn. Right? Well, that's because the cooler the color, meaning blue, that means it burns hotter than the whites or the oranges or the reds. So he measured all of these, you know, scientific trial and error multiple times, came up with this table of how different colors glowed at different temperatures. And then Jeremy Byrne put them to these different colors, he put them to real world light sources. So you have a direct relationship between our real world light sources, what does that color look like, and how is it generated? So when you go buy light bulbs, we talked a little bit about this earlier. You go buy light bulbs, you buy them for how bright they are, and you know, what color are they? You don't want them too yellow. You don't want them too cool or blue. You usually want them cool white or kind of natural light, they call it, which is a little bit towards the whitish side, maybe a little bit of warmth in it, just to make it look natural for us. So you'll see that the sky, let me kind of put this part in an area here. All right, so this right here, this is the normal starting point for most CG color. And most CG color temperature starts at 6,500 degrees. In fact, in RenderMan, in V-Ray, in Arnold, in Unreal, you enable color temperature, they usually give you this kind of neutral 6,500 degree Kelvin color in your light. That's considered kind of average white sunlight, natural light, whitish. All right, as the color temperature starts to fall, it starts to get warmer. So this direction gets warmer. And this direction gets cooler. So by the time you're like between 8 and 10,000 degrees or color temperature, you're going to have bluish looking light. Does that make sense? So today, instead of just putting in color with the eyedropper or going into the color picker, we're going to be enabling the color temperature attribute for our lights and utilizing color temperature. And when you enable it by default, you'll get 6,500 degrees, which is slightly warmer, just ever so slightly warmer than pure white. You'll notice a little bit of a difference. So color temperature, very important. When you're working with environments and trying to mimic real world artificial lights, natural lights, you need to be aware of the color temperature in your lights, because that's going to be part of trying to match the realistic look and feel of an environment. All right, so dome lights, portal lights, they are actually fairly simple to use. So dome lights, this icon right here kind of looks like a wireframe sphere that's in the Arnold shelf. That's how you make them. So we've got dome light here. Create the dome light first. If you need portals, you create the portals afterwards. If you're doing an exterior scene, you don't need portal lights because there are no areas that are blocked. Even if you're, under an overhang or on a porch, I mean, you still got a lot of open area there to let light in. So we use dome lights. We will be using, I would say 98% of the time when you make a dome light, you're going to be putting an image in it, because you want to be able to have some color come in, and that's going to come from the image. And you're also going to want to have light associated with that image. If it's daytime, it's going to be brighter. You can change the intensity of the dome light separate from the amount that you get by default with the image. So the brighter you make it, the brighter the image is going to be. So for the dome light, scaling translation really is not a factor. It is meant to look like it's infinitely far away. And, it'll just keep looking the same until you actually breach the hull of the dome light and go outside of it. So rotation, on the other hand, does matter, because you can rotate the dome light. I would say 98% of the time you rotate it in Y, so that you can change what is viewable to the camera. Now, if you're using an interior scene and you've got a dome light, you're going to be making some portal lights. So these portal lights look a lot like area lights, but the difference is they really have no attributes of their own. They have no intensity on their own. They have no color, temperature. Everything comes from the dome light. So portals are, think of them like slaves of the dome. They really can't function, or drones, they can't function on their own without a dome light. So when you create a dome light, make sure it's selected. If you need a portal, you basically use the icon that is right next to the dome light. Looks like a dome light with a little area light in the middle. That will create a portal. You need another one, select the dome light again, create another one. Move them around, position them to go over the windows and doors of your environment. And they've got a little arrow in the center, just like an area light, that tells you the direction that the light's going to be broadcast. Like I said, once you create one portal light, it shuts down visibility to the camera of the dome. So visibility comes through those portals. And ideally, this is why we do it. We focus the sampling when we render. This way, we're sampling a smaller area than a 360-degree complete environment. Right, so this will make sense when we actually go to demo it also. Now, for mesh lights. Mesh lights are the icon right next to area lights. Again, in the Arnold shelf. So usually what you do to make a mesh light is you select your geometry, click the mesh light button, and what it will do is replace the material that's on that mesh and make it emissive rather than reflective. So when we put a material on any geometry that you've modeled or are working with in a scene, we're telling it to reflect light back, right? We put a Lambert on it, we put an Arnold material on it, any kind of material. We are just basically saying you are reflecting light back into the environment. But as soon as you turn it into a mesh light, it no longer reflects light, it emits light. Here's the kicker, though, with Arnold mesh lights, which personally I find annoying. If you've got a whole bunch of geometry that you want to assign one mesh light to, say, for example, here in our environment, in our room, we've got, I don't know, what are they? 1, 2, 3, 4, 5, 6, 7. So we've got 21 recessed ceiling lights here. Okay. In Arnold, if you want to assign a single mesh light to them all, because honestly, they would all have the same intensity, the same wattage, they're going to be in the same power supply, and they probably all are more or less the same age. So they're all going to be roughly about the same. Why should you have 21 different controls when you can control all of them with a single mesh control? That would be kind of silly, right? But with Arnold, you have to select all your meshes together, combine them, and then assign the mesh to the combined surface. It's an extra step, but totally necessary. Because if you select them all and assign a mesh, whatever the last selection is will get the mesh, and none of the others will get that. That really kind of annoys me because Arnold is the only one to do that. Like RenderMan, V-Ray, you select a bunch of meshes, it assigns however many you select, it assigns that one mesh to all of them without having to combine it. But in Arnold, you must combine in order to have the same mesh light on multiple meshes. Again, does that make sense? All right, so invariably somebody forgets that. So if you see somebody struggling, just remind them, hey, you got like 18 recessed ceiling lights in the interior scene, did you select them all and combine them first before you assigned a mesh light to them? Chances are they probably forgot. So good news is it's not really that difficult. It's just an extra step. Now, if you want to go back to a material, you need to select your mesh again, and you can assign a new material to it. I'll show you a couple of little things with once you make it a mesh light. I'll show you it kind of parents the mesh or the new light to the geometry. And I'll show you where that is, because if you want to make it reflective again, you accidentally selected the wrong surface, made it a light it wasn't supposed to be. You want to assign your AI standard material back to it. I'll show you how to do that. All right. Does that make sense out there in Zoom? Anybody have any questions? Jerry's good. Thank you. Janelle's good. Nelson's good. Joshua's good. Maddie, Deja, Brian, thank you. All right. So let's talk a little bit about high dynamic range images. Typical average images that we get off the internet. Internet like JPEGs or PNGs, they are typically RGB 24-bit images. All right, each channel, red, green, blue, all has 8 bits of information. 8 bits of information is equivalent to 256 levels between absolute dark and absolute light. It's like having, 256 shades of red before it's absolutely black red and absolutely pure white saturated red. So each one of these is 8 bits. 8 plus 8 plus 8, or 8 times 3 is 24. That gives us roughly 16.5 million color variations. So 24-bit images provide us with what we consider to be continuous tone looking images, like we're used to seeing when we look at an actual environment, an actual, we're not looking at a photo, we're looking at the real world. So it gives us quite a few colors. All right, so high dynamic range goes beyond that. So at 8 bits, we get 256 levels. When you've got 32 bits, that's like 8 cubed, I think. No, cubed, squared, cubed, 8 to the 4th power. I think is that right? Does that sound right? Anybody good at math? Because I'm just not that good at it. All right, so let me turn this into scientific because it's a lot easier. All right, so 8 the 4th power. So 4,096 levels between absolute black and absolute white, rather than 256. So a lot more range of information. Now, you are also not limited to the number of channels like you are with an RGB image. So RGB images, 32 bits of information, you're only taking up a few channels in it. You can have billions of bits of information inside an HDR image. Now, developed in the mid-1980s, mostly as a way to, I think it was originally developed for NASA to be able to store high dynamic range telescope and satellite imagery, and be able to keep as much raw information as possible so that they were not limited to the file format of the day, which was TIFFs and JPEGs and stuff like that. Right? This did not really become accessible to us, the consumer, because our digital cameras at the time could only handle about 640, the resolution was like 640 by 480. Once we broke the megapixel barrier for cameras, where we got over 1,000 or over 1,000,000 pixels in an image, then it became accessible to us. Now, when cameras like this first came out, they were like $20,000 for consumers. And most consumers didn't buy them. They were mostly like, photographers, AP photographers, time photographers, people who did it for a living, who worked for big corporations, who could foot the bill for these cameras. But they all kind of helped hasten in the advent of consumer grade electronics that we have now. I mean, most of our phone cameras can shoot 4K. Just to get a camera who could take a 1 meg or a 1K picture was a big deal. All right, give you an idea, mid-1980s, universities, NASA, didn't really become accessible to us to the mid-90s, originally written in the C language, which is kind of like the mother of all modern languages, C, C++, C#, all the variants of it, Perl, Python, Maya's and Mel, which is Maya's embedded language, is C++ based. A lot of code is C++ or C based, I should say. All right, now, there are two common formats today for high dynamic range images. One is the original HDR format developed in the 80s. The other is EXR, which we are using as our output from rendering. Most renderers use EXR as a common high dynamic range or high quality image. You guys saw it with Unreal, right? We set our bunny burn frames to output as EXR. That's a native format in there. You can grab it. Arnold uses it, RenderMan uses it, V-Ray uses it. You can even get it out of Unity, I believe. EXR was written as an alternative to HDR. HDR was good, basic file format, but EXR is a lot more flexible, meaning you can write and alter it much easier. And this was developed by Industrial Light and Magic in 2000, ILM. If you guys aren't familiar with ILM, you're in the wrong industry. Anybody not heard of ILM, Industrial Light and Magic? What's that? What is that? So yeah, they're only one of the biggest effects companies in the world, next to Weta. They've done every Star Wars movie. They've done pretty much every Avengers movie. If it's not Weta or ILM, it's a combination of the two of them, and then all the other little companies after them that they farm out too. They're kind of like little, those are the sharks, And then they take all the big chunks of the fish, and then all the other little bits that are left over, all the other little scavengers come in. Those are all the other effects companies come in, and, you know, not to demean what they do, but they're just so big that they get all the work. They get all the work, they can't do it all, or they know they can't do it all. So they hire companies that they deal with who are reliable, who work with them, give them what they want, and don't really care about being the big dog or the big shark in the tank. You know, they're happy just to be able to have somebody get the work, they do a reliable job, and it's steady. So the reason that this was developed in 2000 is because in 2000, there was a reboot of the Star Wars world, or universe, I should say, right? Episode 1, Phantom Menace. So the reason this is a big deal is because Sony had just developed the first digital 2K cinema camera, not film, but digital cinema camera. And at the time, the best consumer grade electronic video that we had was DVD. DVD was not all that big. DVD was 720 by 480. Or 405, depending on your aspect ratio. So George Lucas, ILM, they were going to shoot with this new Sony HD camera, 2K camera. They wanted to make sure they could keep all of the information without compressing it or losing it, put it into a format that they could retrieve and alter without losing any quality. So HDR obviously was the first choice, but not very friendly, hard to write stuff for, not really open for modify. So Industrial Light and Magic took all of the necessary parts of it and made it into an open source version language. So it is commonly called OpenEXR because it is open source, meaning anybody can use it, anybody can modify it, you just have to give it back to the community. So it quickly became the industry standard because it was every bit as good as HDR, but a lot more flexible, especially for film usage, where you wanted to be able to embed a specular pass, a base pass, a transmission pass. You could put all your lighting, all the different lights onto different layers. You could do a whole lot of things with it without losing information. All right, just trying to put that into context so you understand why we're using OpenEXR. But having said all that, the common HDR images that you find are going to be in the HDR format. High dynamic range images typically were done before Photoshop had a plugin, before there was an actual app that could do it all in one shot. They were done by taking at least 3 different exposures of the same image, special effects outside. So could take 3 different exposures of the same image. One very underexposed, average exposure, and then overexposed. Put them all together and make it so that when you changed intensity, you weren't really changing in, or I should say, when you were changing brightness in the image, you were actually changing intensity because you had a whole range of intensity embedded in the image. So HDR images come in 2 common types. One is called angular, kind of looks like a garden mirror ball, and the other is square or rectangular. This square rectangular image is the preferred choice. Arnold is one of the few renderers around that can actually handle both a light probe, which is what this garden mirror ball looks like, which is really what it is. It can handle angular or light probe images. or spherical or rectangular images, the average ones we're used to seeing. This is the preferred type. You have to really go out of your way to put the other kind in. Don't use the other kind if you find them for free. You can always find better rectangular images because the light probes are usually limited to like 2K. They're okay quality. You know, when HDR images first came out, they were considered like, oh, they were the greatest. But now everything is 4K, 6K, 8K. It kind of makes the other ones, you know, obsolete almost. So when you map an image in to your dome light, it will be in HDR, it will be this rectangular format, and that will be able to give you all the information you need. So just like when you were checking to make sure for project 2, project 3, the rabbit, or the still life, that color management was turned on, we want to make sure it's turned on so that not only light, but we are managing the color too, so that everything looks natural. Now, it should be on by default in the scenes we give you. I made it a point to make sure that they're on, but check anyway. If anybody's trying to use Maya 2022, 2022 has a weird thing of shutting off color management on you. So some of you have been turning in, and I swear they're Maya 2022 files. When I open them up, the color management's turned off. So not only should you still not be using 2022 because it's still too buggy, but you definitely want to make sure it doesn't get turned off on you. All right, so we got a couple other things. The color temperature chart. We also have an LED bulb color temperature document inside the assignment. All of that's right here. Art and Science of Color, shading surfaces. Here's Jeremy Burns' color temperature. If you're logged into Full Sail, you should be able to get right in there and get it. Right, there we go. All right, LED bulb selector, a little bit. We got lumens here. Give you an idea. Arnold standard surface. We're not really going to be doing a whole lot with that yet, but all that information is here. All right. Let's see. Gonna kind of give you a brief overview before we take a break. When we come back from break, I'll start demoing this stuff so you get an idea of how it works and go over, you know, a little more finer detail what the assignments are like. Now, you're still in each environment, the interior and the exterior, you're still going to need to select all the geometry and assign an AI standard surface material to it. However, today, we are going to be throwing a lot more energy at those surfaces, so we're not going to have the usual 0.5 value. The value changes are going to be listed inside whichever environment you're working on. So, for example, you're choosing to do the interior day, you would use this dock with the appropriate set of directions. Now, in here, you'll notice I got a link, but unfortunately, when I converted this to a PDF, it didn't actually keep the link, but you can select it This will take you to a website called HDRI Hub. And if you select the link down here under B, copy it and paste it in, it should take you to the HDRI Hub and a free commercial version of this image that we're going to use for the interior day for our dome light is here, and you can download it. Just going to click download. And there it is. Now, so project 5, you're doing the interior day. Going to set your project when you're working on it to the Maya project folder we provide. Select all the geometry, assign the AI standard material to it. Base weight is still going to be at 1. The base color value, though, will be at 0.18. And specular weight to 0. So I'm going to go over the specifics of this, but this uses a 2 dome light system. 1 dome light is for the actual amount of light in the environment, and the second dome light is for visibility, the dome light image outside. So the reason there's 2 separate ones, we can make the interior bright like it should be without making the image in the dome light so bright you can't see anything. And we use portals, and then we use a directional light for the sun. For the exterior, this one is a little bit simpler, mostly because there's a single dome light. You don't have to worry about portals. And all you're doing is adjusting the dome light, rotating it, in this case, in X, Y, and Z to get the look, increasing the intensity of it. Don't have to worry about portals because it's outside. It's basically an outdoor environment. Adding in the sun. And then we have a close-up shot too. So for project 5, whatever environment you're doing, you are doing 2 renders. One is a long shot, kind of like an establishing shot of the whole environment. The second render is going to be a close-up. We've got either 2 different cameras for it or a camera with 2 bookmarks, depending on which scene you're doing. You should remember bookmarks from project 1, right? You opened it up when the render cam and then picked your bookmark. Well, for the interior, I've got 2 different cameras set up, but for the exterior, it's 1 camera, 2 bookmarks. So it'll take you right there. None of the cameras are locked, so if you accidentally move them, they all have bookmarks so you can get back to them. If you want to lock them, that's totally fine, but I chose not to, just because a lot of times you're not going to get locked cameras if you get a scene. It's either up to you to lock it, or the reason it's not locked is because it's going to be animated later, and you're only working on the environment, and somebody else is doing the animation part of it. So, you know, just get used to working with usually whatever they give you. Now, whichever environment you decide to do for the day, you will do the opposite time of day for the opposite environment. So again, if you choose to do the interior day, you need to do the exterior night. If you do the exterior day, you'll need to do the interior night. Whichever one you choose to do, there's going to be some mesh lights involved for the nighttime scene. May not be able to see them here, but in the close-up, there are these LED light bulbs. Those are your mesh lights. So for the interior night, we have a separate HDR image. Oh, one thing I forgot to mention. For the Zen Garden, we provide the HDR image for you. Why? Well, we have an HDR camera and the environment was right outside our office. So we were able to go out there and take an HDR image for it. For the interior, we weren't able to do that. For the interior night or the day. And I didn't want to use the same Zen garden image in your interior because it looks kind of hokey. So that's why we're sending you also to go get different images. So for the night interior, there's an actual city night lights. And all you do is click the download now button. This one's a little bit bigger. When we come back from break, I'll show you what is useful inside the downloads because they give you a bunch of stuff and a lot of it you don't need. All you need is the one high dynamic range image. All right, so for the nighttime, you've got a dome light. You put your image in, you're going to rotate it, get it set up. You're going to put some portal lights in there too. Even though it's very, very low level light, you don't want noise generated inside there. So we adjust the intensity of that dome light and we start adding in the different mesh lights. So there's recessed lights for the ceiling. We add the arm lamp that's next to the chair and the window. We turn the TV on. We turn the light on the desk, and then the computer's on too. And that makes up your interior nighttime environment. Sort of similar to what you might expect in a normal environment. And then we have a close-up. The good news for you guys is if you have gotten the long shot lighting correct, the close-up is automatically correct. It's part of the environment. We're just focusing in on an area because later on, that's going to be the area of focus for texturing, high detail texturing. All right, so for the exterior night, we provide that HDR image for you, just like we do for the day. So you don't have to go anywhere for that. That's included in your Maya project folder inside source images. Your HDR images in there automatically. All right, so for the nighttime Zen garden, we're going to put the dome light in, rotate it just like we did for the day, but it's going to be a lot darker. And then we're going to start adding lights. Now, the lighting we have in here is based off of some of the reference we're giving you guys. So for the Zen garden, when you download it, you'll get a reference folder and you will get photo reference, which is basically what I gave Frank to model from. So there's the Zen garden kind of trellis area from different angles. This is the final shot that we have for you guys. Of course, we didn't model in tree there. No tree, but the light angle, everything is pretty much identical. So just different, images so you can see what it looks like. Like I said, I recommend going there and seeing it for yourself, but you've got photo images. The reason I provide this is because in the Zen garden, at nighttime, these lights go on and they provide a whole lot of light in the environment. So this is a big giant panorama of the different lights that are there at night. So this one is that big bright overhead light. That's actually the very first light that we give you guys here. That's going to provide that. And then all these other lights that you see behind the camera and alongside of it, they're all part of these little tree lights that are all over. Like all the trees in the Zen garden have little lights that shine up on them, and they create a little bit of nice fill light in the environment. So there's your main kind of overhead big giant building light. Then down here, we got a little bit of light behind the camera, which is basically was a tree light behind the camera. We have a tree light on the left, tree light on the right. And then we have some geometry that you're going to turn on, and you're going to make the candle flames LED bulbs. They're going to be mesh lights, and they're going to provide the illumination for the close-up portion. All right. When we come back, I'll show you some examples of what students have done for the MyComp portion. You know, what kind of environments they've gotten and how they handled it. Anybody have any questions? I mean, that's just kind of a rough overview. We'll get more into detail when we start looking at the actual files. Questions? All right. Nelson's good. Anybody else have questions in Zoom? All right. Jerry's good. Joshua's good. All right. Brian's good. Deja's good. Thank you. All right. So this is a good time to take a break. Let's take a 20-minute break. That'll give me a chance to render out the first part of lecture. And let's come back at, let's see. Yeah, come back at like 3 o'clock. That should be enough time for me to render everything out. So I'll see you guys in about 20 minutes.